It is being recorded. So let's take a look today at lecture 25, graphs of sines. Yes.
You said to bring in the question.
You got a question for me?
You said to like talk to you about it before, like in this album.
Yes. What do you got?
It was the find the exact value of each of those things, trigonometric functions of theta.
Okay, so this is going to be lecture 24, question what?
Question 2.
Question number 2?
Yes.
Okay, so I know we've had some issues with the web services with like a nationwide thing, and we've been having some trouble with that. So we are going to get some leniency on homework. If we didn't get in yesterday, we'll obviously do some leniency on that. I know someone emailed me their homework, that's fine. So if you didn't get in last night, you have a review. Okay, so what's the problem? Finding 6 trig functions for what order they give you?
Of theta, and the point they give me is negative 12, comma 5.
Negative 12, comma 5, and find the 6 trig functions from that point.
Yes.
Okay, so the first thing we're going to do is graph it. Graph that. So let's see here. It's going to be in what quadrant?
2.
2, because it's negative 12 and up 5. So I'm just going to put it like right here. That's going to be negative 12 and then up 5. Something like that. Ooh, it's a terrible long number. Yes, so it's a 5, 12, 13 Pythagorean triple. If you don't know how to do that, just use Pythagoras' theorem to find your h, your hypotenuse. So 5 squared plus negative 12 squared equals the hypotenuse squared. Okay? Now, to kind of save time, I'm going to jump ahead. You will get hypotenuse is 13. Okay? So now we're just going to use SOHCAHTOA. What's the sine of theta?
It's 5
Over.
over 13.
Yep. Opposite over hypotenuse, so 5 over 13. Which then would mean that the cosecant is going to be
13 over 5.
13 over 5. Okay, so then the cosine of theta
Of 5 over 12.
cosine is
Oh,
adjacent over hypotenuse.
yeah, 5 over
That was sine. It would be adjacent over hypotenuse.
13. Is 5 not adjacent?
No.
Thank you.
Remember, adjacent creates the angle.
Oh, I was thinking of opposite for some reason.
Yeah, you're thinking opposite. So, because it can't be 5 over 13 because that's sine.
Yeah.
So it's going to be negative 12 over 13, which should mean then that the secant of theta is going to be,
13 over 12.
don't forget, yeah, or just negative 13 over 12. Yep. Okay, and the last one, tangent of theta. I'm saying like the last two.
5 over negative 12.
Yep. 5 over negative 12, which you can get from your sine over your cosine. So then your cotangent of theta is going to be the reciprocal.
Wait, what's
Opposite over adjacent. Or if you go back to your identity, I think this is maybe where we started our conversation yesterday. Toby, was when we talked about like tangent equals sine over cosine. So tangent equals the sine over the cosine and 5 over negative 12. It's hard to go backwards from there because you still got to get the hypotenuse, but that's one way to. Make a little more sense?
yes?
That one we have to go back to those geometry trig values. Okay? Very good. Okay, so if we need more time on the homework, that's perfectly fine. Take your time, get that done. Once again, send me any questions or bring them. Let's look today at lecture 25. Okay. Okay, so there's a lot to this. I do want to remind you, though, everything we've learned in previous classes when it comes to parent functions and shifting those functions, there's exactly the same with the sine function. It's just we're going to go through, it looks a little different because the sine is a wave, it's periodic. Okay, so we have some unique things with it. So we're going to go through some baby steps. First of all, what characteristics can you tell me, whenever we start with a graph, what characteristics can you tell me about the sine graph? We know it's periodic. What does that mean? Talked about this the other day. What does it mean to be periodic?
Split it up.
What do you mean by split it up? Talk to me more about that.
Like you can break it into two.
Break it into many parts, actually. Okay, it repeats itself over and over and over and over. In fact, it repeats itself infinitely. We go start at 0, go up, come down, go up, and just repeat itself over and over and over forever. Okay, we have that way. Or some other characters you can tell me about the sine function, and I'll give you a little hint here. Those should be arrows. Say it again.
Is it endless?
Put that in math terms.
Alright, and it goes to infinity.
Okay, so I'm gonna say the domain is gonna be all reals. It's endless. It goes infinitely in both directions. Negative infinity, positive infinity. Yes.
Does it have a minimum and maximum?
It absolutely does. In fact, that we call that the range, right? And what is the range?
Y is less than 1 greater than -1.
Okay, so I'm gonna put it in interval notation. Am I gonna use brackets or parentheses?
Honestly, I don't know.
Bracket, if it's but if it's infinity, then it's
Parentheses.
Yeah.
Yes. So the maximum here is 1, right? Does the sign ever actually equal 1? Yes. At pi over 2, it actually equals 1. So parentheses. Does it ever actually equal -1? Yes, it's 3 pi over 2. So -1 to 1. By the way, that's an important concept right there we're going to come back to later on. Okay? So it's periodic, it has a domain of all real numbers, it has a range -1 to 1. What else do we have? What else is on my list?
You want us to draw that?
You might want to sketch that. Yeah. Because once again, that's the parent function. If you're not familiar with it, I would absolutely sketch that. Okay. And then we're going to be adjusting it a little bit today. We're going to be moving it, translating it, shifting it, all those type of things. Okay, what's another characteristic about this one? Comes back to your identities. Ariana is looking it up right now because she knows what it is. She knows she's going to look at the identities. It's not going to be reciprocal or quotient or Pythagorean. It's not going to be periodic. She's going to look at the other one, and she's going to tell me this is some type of function. She knows everyone's looking at her. The pressure is on.
You said it's not, rhetorical.
You want to go with the 50-50?
I like remember how to pronounce the name.
Say what?
If I remember how to pronounce the name. Is it
Okay, so I can tell by your comment you might be in the wrong place.
yeah.
Okay, so I'll give you 50-50. How about that? Or would you rather phone a friend?
I go with Jefferson.
It's too late.
Sorry.
You've already used phone a friend. So is this going to be an even function or an odd function?
It would be even. I'm not even.
It is odd. 50-50. It's going to be an odd function.
Yeah.
So someone else, phone a friend, tell me why is this an odd function? Everyone's pointing to you, Jefferson.
The friend are done.
Defer to Mario.
Oh, I don't even know what we're talking about.
You say I don't know.
Is it because the sign still equals negative?
Say it again.
Because sine theta can equal the negative?
Yes? So sine of theta will equal the sine of, or the negative sine of theta will equal sine of negative theta. The other thing too is if I were to take this whole graph and rotate it 180 degrees around the origin and rotate it, it would be exactly the same. Okay. It's that rotation around the origin. Back in geometry, you talked about 180 degree rotation. You just turn it upside down. Okay, we'll look exactly the same. So it's an odd function. Okay, and probably the most important thing to help us with the next function on, on Thursday is we need to know this order. Okay, where does the parent function start? Well, it always starts at 0. Okay, in this case, it starts at the origin. I'm thinking more of the y value. This is where the y value is. Okay, so it always starts at 0, and then where does it go to? What's the next major point? Then it goes to the maximum. After the maximum, it goes back to 0. Where does it go next? Down to the minimum. And then where does it go? Back to 0. And then it repeats this pattern over and over. It goes 0, max, 0, min, 0, max, 0, min, 0, max, 0, min, 0, max, 0, min, all the way out forever. Okay? Because then it starts to repeat itself. It gets back to where it started. So it starts at 0, it ends at 0, halfway between it's at 0. Okay? Then we hit our maximum. Okay? That's an important concept right there as we look at this graph. Okay, a couple of things. I think we talked about some of these the other day. Remember, this kind of breaks it up into 4 sections, right? We have quadrant 1, we have quadrant 2, we have quadrant 3, quadrant 4. So the period from 0, max, 0, min, 0, that period, and we break it up into 4 equal parts, always. It's always broken up into 4 equal parts. We can shrink it, okay, but you're still going to have 4 equal parts. We can lengthen it, you're still going to have 4 equal parts. One more. Let's go in purple. We have this right here. This line here in the middle. In this case, on the parent graph, that middle line is the x-axis, right? We call that the midline because it's in the middle, right? Now, just like other graphs, I can move graphs up and down, correct? Like if I have x squared, I can move x squared plus 2 and move it up. I can take this entire graph, this midline, and I can move it up, or I can move it down. And there's one more term, and that's the distance from, what's this line called again?
Midline.
Midline to the maximum, right? Over here I have the midline to the, they will always be the same. Okay? And there's a name for it. It's called the amplitude. And the distance from the midline to the maximum and the midline to the minimum will always be the same. That's the characteristic of it. Okay? And I just saw one thing that I failed to put on here with periodic. How long does it take to go through this series from 0 to max, 0 to min, and back to 0? How along the x-axis, how far does it take to do that?
The viewpoints.
No. Look at the x values. When does it come back to 0? 2 pi, right? And where does 2 pi line up with the unit circle? 36 degrees. It's one rotation, right? So this is like one rotation of the unit circle, and that's how long the period is, 2 pi. If you go back to your identities, we talked about periodic elements, okay, or periodic identities. And remember, like if I have something plus 2 pi, Okay, it's just you get rid of 2 pi. 4 pi, 6 pi, you get rid of all those. Okay, so the period is every 2 pi. Amplitude. Forgot the E. Did you notice that?
Yes.
You did notice that? Should have yelled at me. Thank you for being nice. Because it's too early to. Okay. Alright, so we got our characters, we've got the sign graph. Questions on any of that? We gave you some new vocabulary words. We gave you periodic, okay, which define periodic. We know it's 2 pi, define periodic formula. What does it mean? Because when we talk about the function's period a lot, so what does it mean? Give him up. Not good.
I didn't notice.
Didn't know. So what's the period?
Isn't that the code terminal size same?
We could say it that way, yeah. Or it just returns back to where it started. The period, how long does it take to return back to where it started? How long does it take to go from 0, max, 0, min, and back to 0? In 2 pi. So that's the definition of the period. How long it takes to go through all 5 points and return back to its starting point. 1 full revolution of the unit circle, if you will. Okay? All right, we talked about midline, we talked about amplitude. We good with those? Because now we're going to do some changes. Make sure I got all. I think I got everything I'm supposed to. Okay. Elda, you ready? Okay. This is going to get hard. Okay. Prepare yourself. Here we go. Let's go with kind of a general equation. We did this when we talked about quadratics, and when I say we, it means whenever you were in Algebra 2 class. We did this when we talked about exponential, so we'll do it now with a sign graph. So f of x is going to be equal to a times the sine of b x minus c plus d, and I guess that c should be a capital C. Now obviously the a, b, c, and d will be numbers. There will be some sort of value. But I want you to see what do they represent, what do they do. Okay? So let's look at each one specifically. We're going to do each one and then we'll put it all together, hopefully, by the end of class. Okay? Okay, so which letter do you want to start with? Please say the A. Outstanding. Let's look at the A. So A is the only one on here that actually starts with the letter A. The term actually starts with an A. Okay? The A is our amplitude. Okay, so once again, tell me what is the amplitude?
The line divided into quadrants.
Okay, so it's a line from what to what?
Max.
Max to the midline, the minimum to the midline. Okay, so that's the amplitude. Okay, how far up and down above the midline it goes. Okay. So let's look at a basic one. Over here, I'll try to do some examples as we go so you see what they look like. So we have y equals 2 times the sine of theta. Something like that. Okay. So what would that look like when I graph it? Well, I'm going to have, let's see here, here's pi over 2, here's pi, here's 1, 2, 3, -1, -2, -3. So, and you're going to get tired of sketching that little graph. I wish I had it stamped. You can just take it and stamp your notes with it. Okay? Fortunately, I don't have one. You're welcome to go buy one. You'll need it for maybe 2 or 3 days. Now, normally, okay, so on a sine graph, I always start at 0, correct? That's not affected by the amplitude, so I just start at 0. Okay. Now, the next point at pi over 2, normally, that's where I hit my max at 1, correct? Okay, so normally I go from 0 to 1. But since my amplitude is 2, what am I gonna do? At pi over 2, rather than going up to 1, I'm gonna go up to 2. And that amplitude now will be 2 rather than 1. And then we have back down here to 0. What's the next one? Negative 2. I'm going to have 3 pi over 2, and it's going to go down to negative 2. And then back to 0. So rather than, let's go back to my regular one. Rather than going up to 1 here, rather than going up to 1 and down to negative 1, I've gone up to 2 and down to negative 2. So what has that done? It's actually done what to the graph? Stretched it which way? Yeah, stretched it vertically, right? We pulled it and vertically. So we stretched it vertically. That's what the amplitude does. It just changes it above and below. Good with that? Am I going too fast? Do I need to slow down a little bit? There's still some people writing. Speed up just a little bit,
No,
or
slow it down just a
I could have sworn you said speed up.
little. No.
How if I get a drink while you guys finish that?
So this is just A.
This is just A. And we're not done with A. Oh. I knew that drawing was coming. Say it again. Well, of course. How would I compress it? Because normally the amplitude is 1. So what would compress it down? Number less than that. So if I made, 1/2, now it goes from 0 to 1/2 to 0 to negative 1/2. So just push it down. But there's one other thing it could do. What else could that amplitude do? Good guess. Let me give you a hint. Do you remember when we had y equals x squared? Okay, the number in front is what stretched it vertically. Okay, yes. Make it reflect, because what if I have y equals negative x squared? What did that do? It reflected it over the x-axis, right? Put it upside down. So what would? Here's a good one. What would happen if I rather than write it all over again? You guys, let's just write it over again. Y equals negative 2 sine of theta. Okay, Sushi, what would that do to my graph?
Basically reflecting over the x-axis.
Yeah, so rather than going from 0 to the max, I would go from 0 to the minimum. So it just kind of reflects the max and min. So if I look at a graph, and we have pi over 2 and pi, once again, our 4 quadrantals. Okay. And I have 1, 2, 3, negative 1, negative 2, negative 3. So the negative just says, okay, I start at 0, but now my amplitude is negative 2. So I'm going to go down first. I'm going to go down to negative 2, back to 0, up to 2, and back to 0. So just flips it. What are you laughing
It's just like whenever you have your shoulder flip the board.
at? Yeah.
Yeah.
Did it change it somehow?
No, it's just yeah, there you go.
Okay. Okay, so with the negative in front, rather than going up and down, we go down and then up. So it changes it to 0 minimum, 0 maximum, 0. Make sense?
Yes.
All right, let me that's the easiest one.
Oh.
Actually, it's not. There's one that's just as easy. All right. People are still jotting a few things down. In fact, you know what? I'm going to change that to red. So when you guys look at the notes, if you look at it online, you can see I changed that to a negative and that reflects it. But I do want to emphasize though, that going to the minimum and the maximum will always be the same distance, that will never be different. Okay, from the midline, it will always be exactly the same amplitude. Okay. Alright, we're good with the A, the amplitude, what it does. Alright, let's go to B. Now, let's do the easy one first, okay? So rather than doing, I shouldn't have done that. Back up the truck. Because I'm used to going from A to B, we're gonna go to D. We're gonna do the D next. Back to my equation, we're gonna do the D next. So do the first one, do the last one. Now, what happens to a quadratic, let's tie this back to something we already know. What happens to a quadratic if I have x squared plus 2?
Move it horizontally.
Oh, you're so close. Vertical, it moves it up. Moves it up 2 units.
Oh.
You said
No.
horizontal.
But I thought we just did.
No, we stretch it vertically. Now we actually
Stretch.
moved it. Now we actually moved
Now we're actually gonna move the midline.
it.
The D actually moves the midline. It actually is going to take that midline, which is on the x-axis, and I'm going to slide it up or I'm going to slide it down, whichever direction I'm going. And yes, you can move it up fractions, you can move it up decimals. Normally, we're going to move it up integers. Okay? So D just physically moves the midline. So we did a vertical stretch, now we're going to do a vertical shift. Okay? So once again, you all know it's coming. Y equals, let's do something like sine of theta. And notice where the D is, it's outside this little parenthesis. So like plus 1. Sine of theta plus 1. So it means the midline is going to go where? It's on the x-axis. Where's it going to move it? Up 1. Which means where's the maximum going to be? Well, we don't have an amplitude. So it's going up to 2 and down to
1. Or
2.
0.
0. The amplitude is going to go from 0 to 2. Okay? Because we just move everything up 1. Okay? So let's sketch a little graph here. Oh, that's really bad. I apologize. Pi over 2. 2 pi. Oh, you know, I gotta get rid of it.
Tomato.
Tomato what?
Tomato.
I don't understand.
Like throwing tomatoes at you because like it's a bad performance.
It's a horrible performance. Look at that. There we go. All right. So now I've got pi over 2 and pi, 3 pi over 2 and 2 pi. And then I've got 1, 2, 3, -1, -2, -3. Okay, so where does the midline move to? It says the sine of theta, which is just our regular sine theta, but now I move it up to 1. So my midline now becomes here. Now, when we graph quadratics, what did I make, Shalon? What did I make as a dotted line? Do you remember? Not the asymptote.
You're not to remove.
When I sketched
Sorry.
that, what did I make the dotted line?
It's the A.
No?
Oh, there's.
The what? The axis of symmetry, right? We're doing the same thing here, where I'm going to do a dotted line, and I'm going to make it kind of the midline. That's kind of where it's going to go above and below. Okay? So then once again, I start here at the midline. Okay? Because it starts at x equals 0. Start at that point. At pi over 2, it's going to go up to 2. Back to the midline. That's where a lot of kids make the mistake. We're going to go back to 0. You go back to the midline. And then you go down to the minimum. And back to the midline. And all you've done to your graph is you've taken the entire sine graph and you've split it up 1.
So why is the point on 3 pi over 2 and not on 3
Why is the point on?
pi? Oh wait, no.
Because that's the minimum point.
Yeah.
Yep. Good questions.
Good question.
Excellent question. So let's do the one where I put these two concepts, the amplitude and the vertical shift, together. Okay? So I'll do it in a different color. So let's do y is going to equal, and let's go 2 times the sine of theta. Let's go minus. Let's just go radical. Minus 1. Okay? So y equals 2 times, so now I have two things. I've got a vertical shift, and I've got an amplitude change. Okay? So it's going to shift which way, up or down? Down 1, right? So my midline is going to be right here. Okay? That's my midline. So I know I'm going to start here at 0. What am I going to do with my amplitude now? It's going to go up to 1. So pi over 2, it's going to go up 1, 2. Then it's going to come back to 0 at pi. What's going to happen at 3 pi over 2? It's going to go down 2 to negative 3. And then it's going to come back to 0. And there's my shift of my wave. I've expanded the amplitude and I've shifted the midline. What do you got?
It went to 1 instead of 2.
Say it again.
It went.
Well, it's at negative 1, right?
Yeah.
So it goes up 2 units, 0 to 1.
Yes.
So don't think about it's going up to 2, it's going up 2.
Yeah.
It started at negative 1. So. Jacob, you got this?
Jacob's not drawing anything.
Because it's too much noise. I've read my lesson. I can't take it in now.
Okay, so questions on the midline of the amplitude.
Are those the two easy ones?
Which part?
The negative one.
The negative one?
Yeah.
So I took the negative one, that's the midline, so now it's down here. Okay, that's the easy part, just that becomes your new axis, okay? Then you always start at 0. So,
Up 2.
what's that?
Yeah, up 2.
So then at the amplitude, now I go up to 1, 2.
Okay.
Back to 0. Then at the minimum, I go down 2 and back to 0. Did you just ask are these the easy ones?
Yeah.
All right, here we go. You try. So Jacob, you're gonna want to do this on your own. You try one. Okay. Here we go. Let's make one that's really kind of tricky. No, I'm just kidding. Y equals, let's go 3 sine of theta minus 2. Try graphing the new midline, the new amplitude completely on your own. Give it a try.
He hates us.
I hate you. Start with the graph, start with the midline. You know it's going to be 0. There's no negative in front. If I hated you, I could have put a negative in front. 0 max, 0 min, 0.
He took that right.
I kind of did. Maybe too personal.
I really want to go past 3 and just 1 to 3 hours.
In this case, you actually are going to go past 3. Because 3 is, or you're going to go past negative 3, I should say. So, it's just whatever works on the board. And yes, you can go past those. And Margaret, you're going to love me for this. We could go to fractions.
Oh.
Oh.
The midline is at 4.3.
Yeah, that's. No.
Jacob, that was an evil laugh right there.
That was funny.
I'll be able to go.
They're trying to get 12 teams, so I was going to offer to take 2 teams, but everyone wants to have to really sell 2 teams. So, I may be reading that day as well, so you have to.
Yes.
I've heard from Logan, I think Teddy can go, and Hugo told me he can go, I don't know if you want. If Lachlan can't go, I may not take anybody else, so Ford and stuff.
No.
Well, they only, right now, they're only 8 teams.
Oh.
So you only have 7 matches.
Okay.
Maybe you change it.
That's okay. It's not that bad then.
Yeah.
I would have paid that if it was 10 matches.
Let's be honest, you don't want to sit out.
Huh?
You don't want to sit out.
Okay, sometimes I do want to sit out though because I get really tired, especially at the late. That's why we didn't get first place that year ago because I was tired after the first half. You wanted that trophy? Don't lie.
I do. That's all my goal is. Get a trophy in the conference members.
Oh, come on, I messed this up.
Shawan, you good? How'd you guys do last night?
They should have been able.
Oh.
They didn't give any effort.
They beat you 8-0.
No, we should have beaten them.
Oh.
But you lost it.
You lost?
No, we lost 4-3.
Oh.
You lost 4-3?
Crystal Lake.
Oh. Did you beat them earlier this year?
Yeah, we did.
Oh. Interesting.
I didn't like it.
Okay, we need more time, we good? We good? So, Amani, where's the midline? -2. So right here's my midline. You should have started right there. Okay? Now we're going to go above and below that line, how far? 3. So I'm going to start at 0. At pi over 2, I'm going to go up 1, 2, 3. Then I'm going to come back to 0. At 3 pi over 2, where am I going to go down to? -5. Then I'm going to go 1, 2, 3. And then back to 0. And there's my cool looking graph.
Yeah. I left it cold. Yeah. From 0.
All right, so give me a 1 to 5. You guys know the EPR, right? So 1 to 5. It's not 6, 7. Okay, I'm getting some 4s, I'm getting some 3s, I'm getting negative numbers. Jacob's getting -16. Okay, I'm getting a 6, 7 from the back. Elda, 1 through 5. Okay. Okay. It's fair. So the camera sees me. 6, 7.
Oh.
Okay. All right, very good. So that's going to take a little bit of used to, but realize that's just the vertical stuff. That's just a vertical shift down, vertical shift up, and then of course the vertical stretch or compression. Yes.
At the last point, are you supposed to go back to the midline?
Back to the midline. So the better one here is, because I said 0 max, 0 min, 0, that's the parent function, right? What we really should put when we start transitioning them is you go 0, midline, 0, midline, and no, that's not right. Hold on.
0 max.
No, not 0. It should be
Midline.
midline. Right.
Midline max. 0.
Midline,
Oh.
min, midline. Whew, I screwed that one up. Yeah, so rather than 0, we'll go back to the midline. Okay. All right. All right, so if I've done a vertical shift and I've done a vertical stretch, what do I have left? Horizontal. Now this gets a little tricky. Are you ready?
No.
Let's do the vertical shift first. Vertical shift. So that's going to be actually the C. So we're going to do letter C. So we did A, D, now we're doing C. So this is what we call the horizontal shift. If you want to say it this way, kind of in non-math terms, this is changing your starting point. We're simply changing where I start. I've always started right at the y-axis, correct? We went up or down with the midline, but I always started at the y-axis. Now I can change my starting point. Okay? So like if I had, do you remember back when we had quadratic, y equals x squared, if I gave you y equals x minus 3 squared, it was inside, just like the c is inside with the x, okay? What change would that make to the quadratic? Not left
Oh,
through,
right.
because it goes to the opposite, right?
Yeah.
So if it says negative, which we think this way, it's actually to the opposite, plus 3. So we're going to do the same thing with the sign graph. There's going to be something inside here, and we're going to shift the opposite direction, okay? So, let's give you a nice, easy one to start with. Let's go y equals the sine, and then let's go theta minus pi over 2. Sine of theta minus pi over 2. Okay? So the amplitude is still 1, right? I haven't changed my amplitude. My midline is still 0, because I haven't changed the midline. All I'm doing is taking my parent graph and I'm shifting it pi over 2. Okay? So, we'll sketch a little graph. So, oh man, that's terrible.
Yeah, that's a-
I think I'd rather have it blue. Okay, so I'm going to go pi over 2. We're going to have pi. We're going to have 3 pi over 2. And I'm going to make a few extra. 2 pi. Next one is 5 pi over 2. 3 pi.
Yeah.
What's wrong?
She was
I can't read your numbers.
confused.
I'm sorry. This is exactly the same graph I'm doing every time. I just get it's getting smaller and smaller each time. Okay, so let's go 1, 2, 3, -1, -2, -3. Okay. Now normally, I would start right here, correct?
Correct.
That's where I should start on a parent function. But because inside I do negative pi over 2, first of all, which way is it going to shift? Nope. It says negative, but it's inside the parenthesis, so I do the opposite. So it's going to shift it pi over 2, which means that rather than starting here, I'm going to start here. I'm going to slide it over to pi over 2. So there's my new starting point. Margo, I can't read what you think. Still can't read my writing.
She didn't see the 3 pi. She couldn't read.
3 pi. Yeah, so if you haven't seen that, it's pi, 2 pi, 3 pi. Here it's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi. They just go by half pi. Which, you know, what's the point of half a pi?
Boo.
Boo. Did you just boo?
Yeah.
You're so rude. I have that on camera. So, now I haven't changed the width of the period. So the period is still going to go every pi over 2. So normally I would go over pi over 2 and I would go up how far? What's my amplitude? 1. And then I go pi over 2 back to 0. And then pi over 2 down to -1. Then pi over 2 back to 0. And I've taken my parent graph and we've simply taken it and shifted it pi over 2 to the right. Yes.
2 questions.
Yes.
Okay. So when it's positive, it's the same rule, like you shift it negatively,
Yes.
and then would there ever be a time where you don't put in like a value with on like a normal unit circle? Like would you put in a 1 in there like some number?
That's a great question. And I'll tell you, I won't do that for right now at least. Later on, like in another math class, that might happen. Rather than doing 1, rather than pi over 2, we do 1.
Yeah.
Because if you think about what's pi over 2, well, that's like 1.57. So that would be very weird. Okay, it's possible, but it just doesn't fit into our mode that we are right now.
Okay.
So when we shift them, it will always be in radians.
Okay.
Pi over 2, pi over 4, it will be like maybe pi over 8. It could be like 4 pi over 5, something not on the unit circle, but it'll always be in terms of
Okay.
pi. Just making sure. Yeah. That gets a little tricky.
Stop with all these slices.
Stop it all with what? Slices of fun? Okay. Okay, we good? Okay. You ready to try one of these on your own?
No.
Just the phase shift.
Well, I guess let's
Okay, let's do one more phase shift together, or not phase shift, let's do one more horizontal shift.
And then,
And then we'll-
add everything
So
together.
then we'll put the 3 together, and then we'll, maybe save the last one for tomorrow. Next class, we'll see. We'll see. Okay, so let's do another one. Y equals, does someone want to tell me one? The sign of, let's do theta. Let's go plus
3 pi over 2.
3 pi over 2. Wow, you are definitely asking for punishment. So plus 3 pi over 2. Okay, this kind of goes back to what Margot said earlier. We were going to go above 3 or below -3. Now we're going to do a much wider graph. Because I have to go negative 3 pi over 2. Okay. So let's go here. And then let's go. I may have to go further, we'll see. Just remember, this was Jacob's fault.
Thanks,
And
Jen.
Jacob's not even
I
writing
really
it
appreciate
down.
that.
Maybe we should have Jacob come to the board and do it.
Yeah,
Yeah.
go there.
Okay.
So pi over 2, pi, 3 pi over 2.
Hello, lecture.
Wow. You're welcome. Now you have to tell them what you're doing. What color would you like to use? Purple, red, blue? Yeah.
Alright, class. So at this point, we see that as the book see
You
this.
might give them a second to get this right.
Okay, yeah, of course. You guys take your time.
Those of you who purchased graphing composition books are definitely loving what you're doing.
Who the heck bought this?
That's nobody else in the class.
You should have told us.
We good?
No.
Okay. Okay.
Takes patience.
Not as tough as me out
How'd you get this job?
What are your qualifications? Tell us, say, I'm a senior year junior club.
Yeah, what Mr. Phillips said. Looks like we're ready. Alright.
It's only those 3.
Yes.
Mine.
Okay, so we see that 3 pi over 2 is in the parentheses, so we flip that, which then class would be
Negative 3 pi.
exactly. So that will be our starting point. We put a little dot there. And since we see no things out, like what's that word called? Amplitude. So she don't see amplitude within the function or anything else outside of that. We're just gonna go with the normal standard, the good old 1. So we're gonna go up to 1, right? Then we're gonna go back down to 0. And then after that, we're gonna go back to -1. Huh?
We haven't gone
This
to
is
negative
good.
1. Yeah, we haven't gone to negative 1 yet. That's the first time.
Did we go 0?
So we'll go back to -1 again.
Sorry. Oh yeah, that's sorry. I thought I did something wrong there. We're gonna go to -1, right? Then we're gonna go back to 0, and then up to 1, and then you get the rest of it. So here we are. Thank you, class.
I think
Well done.
Thank you.
It's right here, by the way. It's negative.
See you, lecture.
Alright. Better?
Thank you.
That's your
Yes. I'm not qualified.
Not at all.
I thought he did a very good job.
Thank you.
Except for the fact you went back to -1, that's,
Yeah.
you went to -1. But I said the same thing. Sorry? Is that the tomato thing? Okay. Now, I'm just gonna tell you a little, enjoy this one, because when I go to the maximum, I've always gone pi over 2 to the next major spot, right? That's gonna change because we're gonna start compressing it. Okay, so that's what we're gonna get to on B, okay? Alright, so let's have you try one. Okay, you try this one. We're gonna make 3 changes. We're gonna make a vertical shift, we're gonna make an amplitude shift, I'm gonna make a horizontal shift. Is that too much for a Tuesday?
Yes.
I don't think so.
We just got done with
We
Monday.
have exactly 26 minutes.
Sir, I have.
I have plenty of time to get to the horizontal compression too. So, okay, here we go. Try this one. Y equals, maybe not complain as much. Let's really throw this in here. Let's do
Oh.
a reflection as well. Oh my goodness, a -2. Woo. Okay.
I'm scared.
And then we're gonna do sine of
Is it
theta,
always-
not yes.
Is it always gonna be sine? Stop.
You asked the question.
Why are we?
What's the topic of this particular
Oh, sine.
sine and cosine? But I'm telling you right now, if you learn sine, you can do it perfectly well over and over and over. Cosines are very simple shape.
Is it cosine is gonna be?
It's actually just the same thing rather than going
Negative.
0, max, 0, min, 0. It goes max, 0, min, 0,
Oh, so it's
max.
just
Just go to different order.
Oh.
Exactly, everything else is exactly the
Oh, it's
same.
because it starts with one.
Correct. Okay, so here we go. -2, sine of theta. Let's make this one kind of easy. Let's just go pi. And then we're gonna go plus 1. There we go. So we've got a vertical shift of 1, we have an amplitude change of 2, we have a reflection of negative, and we have a horizontal shift of pi. Graph.
You know I am not learning this bill today. No. It's just a saying.
Wait, I'm not sure. Would the +1 like combat with the -2?
No.
No?
No, one just vertically moves the midline and the other one just stretches it or compresses it.
Oh yeah.
Stretching it does.
This is Miss Phillips. She's on the way. Yep. Miss Martin, you're being checked out.
What the heck? I'm a dentist. I have a dentist. I have a dentist appointment now.
Have a good time.
I guess. I hate the dentist. It sucks.
We'll miss you.
I was
No,
supposed to promise us that you're so hot.
For the last
You
one.
liar. Straight up liar.
Now you're all by yourself.
Oh, they're crazy.
Oh.
Language. I do have that report.
So embarrassing. Oh, now it is.
Yeah, but mine is not the first of the page.
You guys know what you do?
We don't really think about it.
Are you not leaving? Oh, you drive.
Yeah, and we also have we have like the Jocelyn thing at 10:20, so I'm like contemplating what should I do go to class.
Jocelyn.
Yeah.
How many people do the class meetings?
Alright.
My copy.
Alright.
Still see some people writing in the middle of the too.
Have you ever lived with them? What? In the classroom?
They don't come out until the 19th.
But we can ask them some.
Why do you know when they come out? It's the 19th.
Okay.
God,
Go.
I messed it up because I forgot about the stuff.
You come check mine. Is this how are you doing?
Can you see if I cook them?
Oh, one of my cupcakes.
Well, we can draw on pasta.
I am making the one.
What? What?
You ready?
No, I was looking at this one here, and I'm like, that's not it.
Oh, I didn't. Okay.
Is this one?
This fills the check mark.
What's that?
The check mark.
Where's the middle?
I always wait to see good. I mean,
So, it never goes above the midline.
Oh, snap. I see. Okay. If this was the midline, would it be correct?
Sorry.
Okay, let's say.
Yeah.
let's go with Wednesday.
Senor. Don't look at the dotted line, look at the straight line.
Look at the what?
Dot,
What's it mean?
yeah, I did it.
You might want to double check. Okay, are we ready?
Yeah.
Yes? Sushi Toby, we ready?
Sure.
Okay, here we go. Where's the midline? Always gotta start with that. Because that's gonna be our main point. So we're gonna go up one. Right here. Boom. There's my midline. But you gotta find out what you're going above and below. Okay, then you probably need to figure out your starting point, right? So where am I gonna put that first 0 at? Well, it shifted over pi to the positive, so it's gonna be right there. Okay? Now, how far above and below am I gonna go? 2, and I'm gonna start by going down. So I'm gonna come over here, I'm gonna go down 2 to -1, back to 0, up to positive 2, back to 0. And there should be my graph. And we can put little arrows because it's gonna continue in that same pattern forever. Monty, you're good? It's cake, right?
This one. Oh,
Why what? So Ron, was yours right?
Yep.
Elda, was yours right?
somewhat.
Somewhat? Jacob can help you. You're what? Alright, see if people still writing, finish their things up.
And this is the characters with some
What is that?
I don't know.
Oh, no, that was really expensive.
Okay, the next one is gonna be our compression, and I think I'll save the math for another day, because it seems like our brains are kind of like fried at the moment, but I want you to see them, okay? So, let's go ahead and show you real quickly, don't put things away, leave your glasses out, okay? So let's look at, Desmond, let's look at this, it's like I planned this, everything should be out here ready to go, look at that, beautiful. Please don't go away. Why did you go away?
You probably didn't save it.
Oh my God.
Why did that go away?
You probably didn't save it.
Like that.
I don't need to save it. I just minimize the window.
That's unfortunate.
Can I go back? Will it bring everything?
No.
Oh, that's so unfortunate.
No.
You should have saved it.
Everything was ready to go.
That would make me
Dang. Okay. All right, here we go. We know the sine of x. Piece of cake, right? All right, what did we do first? What's the first thing we did?
mad.
Amplitude. So 2 times the sine. Yes, I'm very upset at the moment. Sine of x. And it changed it, right? What if I put a negative in front of it?
It'll start. Sure.
Reflects it. Very good. Okay, then what did we do?
We did D.
Sine
We moved the little line.
of x, and then we did like maybe plus 3. Split it up. Okay. Okay, and then we did, well, if I did something else with it, like 4. Makes it bigger, right? Well, if I do a negative in front of the 4, it just reflects it, right? Okay, let's get rid of those. Then what did I do? I started putting something inside here, right? So we did something like the sine of x. Oh, back up. I had this already. So then we did maybe plus pi. So I've taken it, and rather than starting here, I started over here. And made our fluctuation there. Okay. Now let's do 1. So when I add something, like I add something to the outside, okay, it simply shifted up or down, right? When I add something to the inside, it shifts it left or right, correct? So adding or subtracting, I'm just shifting. Doesn't change the shape of it. When I multiplied out the outside by the -2, that actually changed the shape, right? It stretched it. So how am I then going to stretch or compress horizontally? Multiply or divide, okay? So let's go back here to something like, let's go here, and let's go sine, and then let's go parentheses 3x. Okay. And you can see we took the wave and we compressed it. What does the 3 actually mean? That's what I want to kind of get across today before we leave. What does that 3 right there actually mean? Okay, so if you look at the graph from, whoops, let's go with the red one. So with the red one, I go from 0 to 2 pi, I've done how many periods? From 0 to 2 pi, I've done 1 period. I've gone from 0 to max, 0 to min, 0. I've done 1 period, right? Well, on the one when I did the 3, from 0 to 2 pi, how many have I done? 1, 2, 3. The 3 tells me how many times I'm going to run through the period between 0 and 2 pi. That's all it tells me. Okay? So it's going to be, so its period is going to be 2 pi over 3. It's going to be a third as long because we're going to go through it 3 times. Okay? So what's going to happen when I put in a 2 here? Let's get rid of this. Get rid of this one. What's going to happen when I put in a 2? It's going to go between 0 and 2 pi. It's going to do 1, 2 periods. Okay? What if I put in 5 here? It's going to go 1, let's see, here's 2 pi's right here. It's going to go 1, 2, 3, 4, 5. Say what? So what you're going to have to draw for me is just 1 period. You don't have to draw that right in there. That's all you're going to have to draw. It's just going to be shrunk. Okay, we're going to show you how to do that next class. Okay? We're going to compress it, and you're just going to have to show me that 1 period. But I want you to see what the 5 means. So, what would mean if I put in here 0.5? Between 0 and 2 pi, I've just gone through half of it. which means it's gonna take me twice as long to get through a full pi. It's gonna take me 4 pi to get all the way through it. So I've stretched it horizontally.
Halfway through
Between 0 and 2 pi, because that's the period of our sine graph, I'm only gonna get through half the period.
so. Can you press on the button?
Which one?
There? But it's still going up in the middle? Because.
So basically get rid of half the pie.
It stretches it. So rather than going from, let's go back to our parent graph. Okay, this is my parent one, right? So here is where I should get back to 0. I should get back to 2 pi. But I've stretched it, so I'm not actually getting back to there until I get to 4 pi. And I've taken the phase and I've stretched it.
I thought the whole thing of 2 pi is that once you do 2 pi, you're at a full revolution.
Of the parent graph. But now we can stretch it.
Okay.
And we can compress it, we can make it
So
smaller.
it's
But
like changing our unit circle.
think of it more like you're changing the quadratic. You're taking a parabola and you're moving and shifting and switching different directions. You're not really changing, because the unit circle always has a radius of 1. These don't have an amplitude of 1. They can change the amplitude. So a little different. But, okay, so that's what we'll do tomorrow. We'll work on changing that shift, that not tomorrow, the next day, changing that horizontal shift. Okay? You good?
Yeah.
Alright, so we've done 3 of the 4. The last one is the kind of most difficult. We'll talk about it then. Have a fantastic day. You can start working on homework. Those of you who did not finish homework yesterday, I understand.